My name is Jijendra, Solid Mechanics. My topic is about Euler's column theory. Euler's theory of columns relate buckling strength of column to different types of column supports. According to Euler's theorem of column, failure of column occurs either due to the buckling load or due to the buckling criteria. Euler's theory of columns is a very important concept for designing the column type members and also for designing of the struts. This theorem is used to calculate the critical buckling load on the column. Columns and struts. Columns and struts are the structural members used to resist compressive load. Struts are only designed to resist the compressive load, but the column is designed to take minimum of compressive strength and buckling load. A structural member subjected to an axial compressive force is called strut. Per A structural member subjected to an axial compressive force is called a strut. Per definition, strut may be horizontal, inclined, or even vertical. The vertical strut is called a column. Assumptions of Euler's column theory. The assumptions of Euler's column theory are mentioned below. Axis of the column is perfectly straight when unloaded. The thrust line coincides exactly with the unstrained axis of the column. Flexural rigidity is uniform. Material is isotropic and homogeneous. Means these are the assumptions when we are uh, doing Euler's theory of column. We need to concentrate on these assumptions. If a column is unloaded, is must be a perfectly, it must be in straight. It must be flexural rigidity in uniform throughout the column. The material must be homogeneous. Homogeneous means accept it must be same throughout the material is known as homogeneous. And limitations of Euler's formula. The limitations of Euler's theory of column is the limiting conditions of a theory for the particular condition on which the theory fails. Here are the few points for which Euler's theory become violated, and these conditions is called the limitations of theory. The column always has crookedness and the load may not be exactly axial. This formula buckling takes into account the axial stresses, and this formula gives the buckling load may be much more than the actual buckling or crippling. It's also known as a crippling load. The maximum load at which the column tends to have lateral displacement or tends to buckle is known as buckling or crippling load. The load column can be analyzed with Euler's column formula can be given as P suffix E is equal to pi square EL by LE square, where E is modulus of rigidity, LE is equal to effective length of column, and I is equal to moment of inertia of column section. For both the ends are hinged. In case of both the in case of the column hinged at both ends, LE is equal to L. P, the formula for both ends are hinged. This is the diagram we can see here. Both sides are hinged with a column. Then it gives a curve shape, and the formula for both end hinged P is equal to pi square EL by L square, where P is equal to allowable load, E is equal to modulus of elasticity, and the units is Newton per meter square. L is equal to length of the column, units meter, I is equal to moment of inertia, and the units is meter power 4. For one end and fixed, for one end fixed and the other end free. In case of the column, one end is fixed and other end free. Le is equal to 2l. This is the diagram. This end is fixed with the origin, and the other end is free in nature, and the length is L, and the formula is for one end fixed and other end is free. P suffix C is equal to pi square EL by 4 L square. For both ends are fixed. If a column is fixed with both end, this is the diagram. If both ends are fixed, the length will be L, and it tends a curve in this case of column with both ends are fixed, Le is equal to L by 2, and the formula for both ends fixed, Pe is equal to 4 pi square Ei by 4L square. Effective length for different end conditions. There will be some effective length for the different ends of conductions. Effective length is nothing but the length of a column that is affected used to resist compressive load. As we have seen in previous slides, there are the diagrams. We have seen due to the compressive load, the cross section length is increased, and the cross section area is increased, and the length is decreased in every diagram. So the compressive load is used. The effective length depends on the type of end conditions. Here the value of effective length for some end condition is given in the tabular form. End condition LE, both ends are hinged L, one end and fixed, other end is free, 2L it represents. Both ends are fixed L by 2, one end is fixed and other end is hinged L by root 2. Slenderness ratios is the ratio of compressive member is defined as the ratio of its effective length to least radius of gyroscope. Slenderness ratio is represented by capital S. Le by K is equal to effective length of member by least radius of gyration. Um, this is the table. This is the table shows the type of columns and the slenderness ratios. For short column, slenderness ratio is 0 to 40, and the intermediate column, the slenderness ratio is 40 to 125, and the type of column is long column. Slenderness ratio will be more than 125. Modes of failure column. The modes of failure of a column depends upon the various parameters. These parameters consist of a slenderness ratio, effective length. Types in this tabular form we can see the modes of failure for a columns like a short column, long column and intermediate column. What is the failure occurs in a column and how it will be take place. For short column, the mode of failure is crushing, and long column the mode of failure is buckling. Intermediate column, the mode of failure is combined crushing and buckling, both. Rank is formula for columns. It is an empirical formula takes into crushing PCS Euler's critical load PR. PR is equal to crippling load by Rank's formula. PCS is equal to sigma CS. A is equal to ultimate crushing load for column. 1 by PR is equal to 1 by PCS plus 1 by PE. PR is equal to crippling load by Rank's formula. PCS is equal to sigma CS. A is equal to ultimate crushing load for column, where A is equal to cross section R of column, K is equal to least radius of gyration, A is equal to Rank's constant. In this is the rank is formulas for column. P is equal to pi square el by l square. L square is equal to crippling load obtained by Eulera's formula. And the final formula is PR is equal to sigma CS A by 1 plus A into LE by K whole square. L is equal to AK square. L is equal to AK square. Thank you.